Good morning and welcome to the Science Station, exploring gene drive research. My name is Cam and today I'm here with an expert in the subject of gene drive research. Please welcome the infamous Dr. Lucy Caldwell.
Thanks for having me here on the Science Station, Cam.
For those listeners out there who are unfamiliar with the topic, gene drive changes the genetic code in an organism and forces that new gene to be dominant in the following generations. The new gene overpowers the old gene almost completely by using the device CRISPR, which takes out a certain part of a genome and replaces it with a new genetically modified set of genes. It replicates itself and cuts out the same certain part of the genome of its mates and replaces it with the genetically modified gene.
Exactly that. Gene drive research could help us wipe out diseases such as Lyme disease and malaria. This research is an amazing advancement in science. We could genetically alter species to benefit them and humans.
The concept is fascinating, but aren't there some risks involved?
Of course. The research is fairly new. Scientists have never tried this, so once we do it, there's no going back. It must be done exactly right. But say in the case of malaria, there wouldn't be as many risks in it because we are only changing a very specific part of the genome. There is a risk that the malaria could also adapt to the new genes and could turn it into something worse or different. It is a possibility that this advancement could be weaponized. The CRISPR device could be used to make the mosquitoes able to carry more or worse diseases than just malaria. They could genetically alter different species to carry certain diseases, becoming threats to us and other organisms. Additionally, if the modifications end up harming the organism, the modified genes are dominant and will affect the entire species over time, becoming a threat to the species' existence.
Why do scientists want to pursue this practice?
Well, there are many pros. If we have success with this research and using the CRISPR device to alter genomes, we could be saving a lot of lives and stopping malaria and various diseases for good. Definitely a route worth pursuing.
What happens when humans artificially alter an organism?
Well, we are hoping to permanently change the genomes that carry certain diseases. This will reduce the spread of various diseases and will be a huge advancement not only for science, but for medical research and mankind.
Wow. So, what is a daisy drive, and why is it a safer method of gene drives?
Daisy drives are like a weaker gene drive that only affects the organisms local to the environment. A daisy drive separates the modified components throughout the organism's genome, making them unable to be copied by themselves. Daisy drives involves different elements being dependent on each other, so after time mixing with natural organisms, the daisy drive effects will run out of fuel and die off, meaning that changes made by the daisy drive are temporary and confined to the local area. It is safer because it is local, and it will eventually die off. CRISPR makes sure there is no DNA level similarity between elements, meaning that if in the rare occasion that all the genes are similar to the added elements, they could spread faster and never die off, but with CRISPR, it won't happen.
So, do you agree with the practice of humans altering genomes of species?
No, I think that we shouldn't look to alter different species. Instead of investing in this research, we can invest in ways to treat these diseases once someone is infected. It is a great advancement in science, however, it could easily be harnessed for different purposes in the future. If we are constantly changing qualities of different species, where does it stop? This scientific advancement could be weaponized and quickly become a danger.
Wow, that is very well said. Well, that's it, folks. Thank you to Dr. Caldwell here, and we'll see you next time on the Science Station.